For this exercise, we're going to take an RBD simulation, or using the bullet solver, and emit smoke from these pieces as they burst out. So I created an RBD sim and wrote it out. Pretty basic. So that's what we got. If you go in here, you can see how I made it. I'll just go through it really quickly. Just gonna turn smeared shaded. Started with a box, and a sphere, noisy sphere. Did a cookie on the box, so we're left with this. These are the pieces I want. I did a VDB from Poly, scattered some points in it, and then I used this guy to set the initial velocity, because each point will represent a piece. So if you jump in here, I'm just randomizing based on the point number, so each point will have a slightly different value. So my velocity is 0, 13, 0, but I'm multiplying that by this random number, which is between 0 and 1, but doing a slight exponent. And then I'm feeding this into a transform matrix. Now a transform matrix is just like a transform SOP, except a transform SOP does the transform on the entire group, and it's only modifying position. The transform matrix does exactly the same thing as a transform SOP, except you can do it on a per point basis, so you can vary where the points are going, and you can do it on you can modify any vector you want, not just position. So it gives you a bit more flexibility. So I'm basically taking this arbitrary vector and then multiplying, so it's between 0 and 13. Most of them are going to be closer to the 0. And then I'm also taking a randomized value and varying the rotation between negative 25 and 25 degrees in Y, 5 degrees and 50 in Z, and stuffing that in velocity. If we turn this on, this should be our... there we go. Now this thing is something that annoys me. I'm not sure why they look like this. This is basically the opposite direction of the velocity vector. These are called point trails, and I swear in Houdini 12 they had these as just velocity. So in our geometry tab or guides tab, scale vectors, if we did a -1, this is what actually the velocities look like. So I've slightly rotated them on the y-axis and on the z-axis. So I feed that into our Voronoi fracture. Now this assemble guy is turning this into packed primitives. Here you can see it's made up of a bunch of polys, points, etc., just like standard geometry. And Houdini 13 now comes with packed primitives, and there's actually a bullet masterclass on side effects. It's like a 50-minute long video. If you take a look at that, it kind of breaks down what's going on, but it essentially converts each one of these pieces into a single prim and stores the data necessary onto that prim. And it makes doing bullet simulations and such much, much faster. Inside the DOP network, I'm bringing these pieces in as the RBD packed object, just setting a couple parameters, plugging that into a bullet sim. This makes it multi-threaded, and having it collide with this ground. The ground is just the inverse cookie to this guy. I'm editing it just to make it a bit larger, remeshing just so it's kind of more even topology. Not sure if that really matters, but I do it anyways. And then I write it out. So we are left with this. So I've included these BGO files as well in the download section. So just you can write it out yourself via this guy, this ROP geometry, or you can just source what I already did. It's a pretty quick simulation. So we've got our pieces. These pieces are what we're going to source our smoke from. So let's create a fluid source. We're going to build everything from scratch. because I think it is very important to know, even though those shelf tools are great to use to get things set up, especially when learning, it's good to just do things from scratch so you can learn it better and learn what's going on. So fluid source, we will set container settings. We will switch from source fuel to source smoke, just to make sure it initializes our density and temperature and such. But we see that we don't have any visualization. It's created our necessary fields, which is great. But the one thing, as I mentioned before, up here we are doing packed primitives. So in order for volumes and such to work, we have to convert these or unpack these back to their original poly state, basically back to where they were at this stage. We can do that using an unpack SOP. So now we can see we're back to the polys, or here is packed fragments. Alright, so now we're getting something, but it's heavily kind of mushed together. Let's turn our division size to 0.4, and under the noise tab, let's set our element size to 0.4 just to kind of break it up a bit. We can turn on our cell influence, and let's kind of increase their frequency a bit. Our cell settings. Let's create our DOP network now for fluid simulation. Let's jump inside and let's create a smoke object. Now this is just going to give us our domain. Let's create a smoke solver. We need to plug our smoke object into the first input. Now we want to source our volume. We're going to want some gravity. Alright, so this is essentially our framework. We also want the resize. So dynamic, gas resize, fluid dynamic. That's the guy we want, and he goes in the first input. Our source volume, we want to source smoke, so I'm just going to initialize it. And our volume path is fluid source. We hit play. Alright, well, we need to make our domain quite a bit bigger, as that's not really working for us. So in order to get kind of an appropriate size, I could go up here and take a look and say, okay, the size of this is 1.6 by this, but I want to do it more like on the last frame and base the bounds of our fluid sim based on this. So I'm going to use a time shift and delete channels. So we're going to now just lock this to our last frame and create a null, and we'll call this out bounds. Now inside our DOP network, let's just rename DOPNet Smoke Sim. Oh, I'm on the 50th frame, so I hit escape to interrupt that, and we'll go back to the first frame. So smoke object, the size. We can use an expression, bbox, point to out bounds, d_x size. This will return our x size, the y size, and the z size. And then we can also use this expression centroid to get the center of the bounding box. Ah, okay, I'm looking, that piece there has fallen off the edge. So that's why our box is that size. So I do want to adjust this so we can create a bound stop after the time shift. And upper padding, we can set it to like 4. Lower padding, we can bring it back up. So it's right around there. That looks good. Oh, and let's give some padding on the back. There. Alright, so this will be our max bounds. Now if we hit play, oh, now I can't see anything because I'm in wireframe mode. If I hit W, should be able to see, yeah. Alright, but we can see it's pretty coarse right now. So we are going to want to up the resolution. But we'll take a look at doing this as well as adding some shape and whatnot in the next video. This is what we currently have. We can see our simulation's pretty coarse, it's low res. So we need to adjust a few things. First, we're currently emitting every single frame. Well, on our source volume, we only want to emit, say, the first 20 frames. So we can just put an expression in here, $FF less than 20. So this will evaluate to only sim the first 20 frames. The other thing, let's turn our resolution down to 0.1. Well, let's do 0.125. We hit play now. Now you can see at the beginning we're getting some clipping on our density, and the reason for that is our resize, yes, it is trying to resize based around the density volume, but the other thing is we need to increase our padding. When you have fast moving objects, you need to generally pad it a bit more or else it'll clip. So now we can see by adding that it's not clipping that much. So this will emit the first 20 frames and then stop emitting. Now the other thing I'd like to do is bring in our collision objects. So static object and out ground. And let's also bring in our pieces. By bringing those guys in as well, or is that what we want? Oh no, we want it after the sim. Out, we'll just call it out rocks. Out rocks. Now we can create a merge, select these two and feed them both in. Create another merge, plug this guy in, plug that guy in. Well, plug it into the gravity. Okay, I'm just going to pause it while it sims. And this is what we're left with. And one thing I forgot to do is our pieces are not moving. I need to tick on Use Deforming Geometry. Under the Collisions tab, we will set this to by size. Just keep that at 0.1. And now when I hit play, yeah, these guys are moving. Alright, well, pause. And this is what we have now. So we're getting better. I would like to introduce some turbulence now to our simulation. Let's create a gas turbulence. And we're also going to add some dissipation. So let's create a merge. And that goes in the velocity update. So we hit play, and one thing we can do, I'll stop it just right here, just to visualize our turbulence, we can tick on Visualize Turbulence. So if we turn our scale up, and maybe the swirl size, we want to increase the frequency, so we're going to turn the size down so we get more kind of swirling. And I think we're going to need to go higher res now on our sim just to read this a bit better, because right now it's still just pretty coarse. You can hit escape at any point to interrupt your sim, and it generally does it right then and there, so that's a great feature. Oh, let's also dial our gas dissipate. Evaporation, we'll just set this to 0.3 as well. And diffusion, this is going to blur the density field. We'll just set this to 0.05 just to do a slight blur on it over time, just so it all kind of starts to blend together. And our resolution now I'm going to set to 0.08. So I'll hit play, and I'm going to pause it and let this go. This is what we have. So it's looking bit more promising. One thing though that I'd like to change is at the end here it's still fairly turbulent, and I want, as the density dissipates, I want the turbulence to kind of die down. So one thing we can use to control how much turbulence we're applying to our smoke sim is on the gas turbulence we have this control settings tab. And if you tick on control field, it will use whatever field you specify. By default, it's going to use the density. And how much do you want this density to influence the control field? By setting it to 1, it's going to entirely look up the density field, and it's going to basically act like a multiplier. You can remap it. By default, it's just a linear thing, but you can obviously remap how you need it. So let me go ahead and kick that off. So now when I play, you can see this stuff, it kind of just lingers. It's not still swirling around as it dissipates. So I think it gives it a bit more kind of natural look to it. Now the other thing I'd like to do is, you can see, like here's a good example. We have just this solid shape, and oftentimes you'll get these kind of mushroom cloud shapes, but it's just a pretty hard-edged kind of look. I want to break this up. So what the gas turbulence is doing, it's creating all these kind of general gross motion swirls and stuff over the whole velocity field. We can also introduce a gas disturbance field, or gas disturbance microsolver. Oh, I need to hit escape, go back to frame 1. And what this will do is it will break up the using noise, but it'll break up based on the density value. So for example, so say this is our shape, this is our density. What it will do is it'll look at the density, and this is where, you know, the center is going to be the most dense area, and it's going to eventually fade off as it gets to the edges. Well, this cutoff value over here, it's going to say any density value less then 0.1, it's going to apply as noise to. It's going to ignore everything inside. So 0.1, it'll apply just noise to the edges. So this is a great tool for breaking up those kind of bulbous solid shapes. So it'll only apply noise to here and leave the rest of it alone. The block size is basically the frequency for the noise. Disturbance is like the amplitude, how much you want to apply. So let's set this cutoff to 0.5. We'll set the disturbance to 5, and we'll set the block size to 0.1. We'll hit play, and let me pause it. And this is what we get. So it's still kind of bulbous, but let's also go to back to the SOP level and create a DOP import fields. Let's drag our DOP network up in there, and the name of our smoke object is smoke object 1. We could name that more appropriate, but I didn't, so just put default object smoke object 1. This is a preset, so it'll import all the necessary fields. So select smoke. So it's going to bring in density, velocity, rest field if you have it, and temperature if you have it. These are mainly used more for the rendering side of things. The reason I'm bringing this out is, well, one, this is how you would bring your fields into SOP so you can render it or use the velocity field to maybe advect particles or you know, to continue to modify outside the sim. But the other reason is you're noticing this is all looking very flat. Houdini does a much better job displaying these volumes when there is a light present. I'm just going to kind of go above, hold down the control key and click on the spotlight button, and it'll automatically put the spotlight where your viewport is set to. Okay, so we get a bit more shading now. You can see on this side. Now the other thing is we are emitting a constant rate of density, and generally when a little burst happens, most of that is spewed at the beginning, right when that impact happens, and then as the first split second, it quickly diminishes. So on our source volume, under scale source volume, I'm going to fit our frame between 1 and 3, and we will say emit 1.5 times the density and then taper that down to 0.5. And let's copy and paste this in the velocity too. But we'll do the first 5 frames. We'll scale the velocity up by a factor of 3 and then go down to 0.75 after the 5th frame, just so we get that bigger punch. And then one more thing I'd like to do under our smoke object, let's turn this down to 0.05. So it's getting a bit higher, but in the end, you know, these sims are relatively quick. You know, I'm able to sim it in a couple minutes. So if you get into the 20-minute, 30-minute range, that's okay. It obviously depends where the camera is going to be. We can push it a bit more, that's for sure. So I'm going to kick this off, and I'll pause it. And this is what we have. So I think this is working much better. You can see also by increasing the resolution, it is breaking up that leading edge. One thing I am noticing is we are getting a little bit of clipping here, and that's due to our padding. We probably need to pad it a bit more, but for the sake of this exercise, this is good enough for me. But I think it's looking pretty cool. Now, in order to see this volume shaded, we do need to go up into the SOPs level. I think it's looking pretty cool.